Welcome, this is section 9.1. Before you start looking at this video, I highly recommend reading your textbook, your notes, and coming to this one, as these are problems from your homework. This is just your homework help. So let's go ahead and take a look at the definition of limits. Before I jump deeper into the topic, let me give you a simple example of what a limit is. Let's say it's a sunny morning, it's a rainy morning, and you pour a hot cup of coffee into a mug. And you're busy doing math problems, you forget, you let it sit. Now, its temperature will approach the room temperature, but technically, it won't exactly be the room temperature. So, limit is what is happening to the y value, what is happening to the y value when x is approaching certain value. Does this make sense? So you pour a hot cup of coffee, you let it sit in the room on your table, and you're trying to see what is happening to the temperature. It will not exactly be the temperature of the room, but yes, it will approach to certain temperature. Does that sound silly? But that's something I could just think of because I have a cup of coffee with me. That's another way to approach limit. Or let's just say you're eating half a chocolate bar. You start by eating half of a chocolate bar, then eat the other half, and then eat the other half, and then eat the other half. So technically, you will never finish the chocolate bar, but you want to see where you approach. So that's exactly what limit is. You're trying to see what is happening to the function value when x value approaches c. One-sided limit. Now let me go ahead. So if I have a c value here on my x-axis, I can approach the c value from right-hand side, or I can approach the c value from the left-hand side. When I'm approaching from the left-hand side, I represent it as limit x approaching c from negative side. When I approach from the right-hand side, I represent as limit x goes to c from the positive side. So you have to remember that if it's negative, you're approaching from the left side. If it's positive, you're approaching from the right side. I would highly recommend just making sure you can use a note card in your test. So I would highly recommend writing all the formulas down that you think you might get confused while taking a test. So again, let's go ahead and take a look at the formulas. Limit of a constant is always going to be a constant. Limit of x when x approaches c is c. Limit of f of x plus g of x is limit of f of x, x going to c, limit of g of x. If it's a subtraction, you subtract the limits. If it's a constant, you pull the constant out. If it's a multiplication, it's f of x times g of x. If it's a division, you separate the limits. If it's a square root, you take the limit inside to the function. Okay, so make sure you have all of these while you're doing your problems because it makes much more sense then. Let's go ahead and take a look at the example from your textbook. Sometimes I pick odd numbers, sometimes I pick even, but I make sure I cover pretty much every problem. Now it says use the graph of the function f shown to estimate the indicated limits and the function value. They're asking me to complete. I do have answers here so that I can see and you can see that we're on the right track. Okay, so let's go ahead and see what the first question says. It says find the limit of f of x, and it says select the right answer and what's happening. Here, my function, let me go ahead. Here, x is going, the limit x goes to 0 plus sign from the positive side. So let me expand this one. And here, I'm coming from the positive side. When x, let me use a darker color. So I'm approaching x from the positive side, and I'm trying to see what is happening to the value. Where is my 0? My 0 is right here. So it says limit x approaches 0 from the positive side. So I'm approaching it from the positive side. Let me redo this one. Approaching from the positive side, I want to see what is happening to the function value. So this is 1, this is 2. Remember, you are approaching x from the positive side, but you're seeing what is happening to the function. Where is the function? I'm going to look at the graph. Where is my graph? My graph is right here. So what is happening? The function is approaching 2. Keep in mind, when you see an open circle, this is the function value is not 2, but it's just approaching 2. So limit x goes to 0 from the positive side, f of x is equal to 2 because it's approaching the number 2. Now let's go ahead and take a look at the answer, and that is correct. Now let's see what happens when I approach from the negative side. I'm going to use a different color. So I'm getting to 0 from the negative side, but I'm trying to see what is happening to my function. What's happening to my function? The function is still going to positive 2. Very good. So limit x, why am I writing it here? I have no idea. Let me write it here. So I have limit x goes to 0 from negative side. The function value is positive 2. Now, the next question is, the function approaches positive 2. Let me rephrase that. Now, so when I'm approaching from the positive side, using a different color, when I'm approaching 0 from the positive side, I know my function value approaches 2. When I'm approaching from the negative side, I know my function value approaches 2. But what exactly is the function value? Look closer. If you see an open circle, that means the function value does not exist. That's a 0. They're telling you, hey, I am getting closer to 2, but the function value does not exist. So there you go. So limit, it goes to positive 2, negative 2, but f of x 0, the function value, it's right here. The function value does not exist at 0. Now let me quickly go ahead and rephrase this one. If you have different color, of course, limit x goes to 0 from the positive side of the function f of x, and limit x approaches 0 from the negative side of the function. As you can see, both of these are 2. That means my limit x goes to 0 is 2. Now, let's just say one is 2 and the other one is 3. When the limits don't match, when you're approaching that particular value from both sides, then you would say limit x approaches 0 for the function f of x does not exist. But in this case, both of them are 2. As you can see, both of them are 2. So when the limit x approaches 0, the function value is 2. But if they're not equal, then the limit does not exist. I think we will see examples like that as well. Let's go ahead and take a look at the next one. Again, if this is fast or this is too slow, you can always use the controls in your Canvas or in your video and make sure you have it custom to your speed. Let's go ahead and see the next one. Find the limit if it exists. And they're asking me x approaches negative 8, and I have the function 8x plus 3. So I'm going to use the limit formulas, that is all the way up here. You should have a copy of this while you're doing the problems. And this is limit x approaches negative 8. 8x, remember I separate the limits. Limit x approaches negative 8, positive 3. Now you might ask, Miss, are we supposed to do this all the time? No, you don't have to. If you know the limits and if you know the values, that's absolutely okay. You don't have to do it. I'm doing it so you can understand. Now the best part is this is a constant. Limit of a constant is a constant because there is no x value. Now as you can see, 8 is a constant. 8 comes out. Limit of x approaching negative 8. Go back to the formula and this whole thing will be negative 8. So when I rewrite it, it's going to be 8 times negative 8 plus 3. And 8 times negative 8 is negative 64. Negative 64 plus 3 is negative 61. And that is your final answer. Let's check. There we have it, negative 61. Okay, again, always limit of a constant is the constant. If you see a coefficient, you bring it outside. x approaching -8, limit of x is -8. Again, have those formulas with you at all times. Let's see. Let's look at the next one. Here, I'm going to separate the limits. So what I'm going to do is I'm going to have limit of x approaching -1. My numerator is x squared minus 2 divided by limit. Remember the limit formulas. I divide the limits. 1 minus x. Now, once I'm here, I will separate the limits further. This is limit x approaching -1, x squared minus limit x approaching -1 to limit. Now you might ask, Miss, am I supposed to do all of this? Like I said, you don't have to. This is just for me to show you that these are the steps. Approaching -1 of x. Again, this is a constant. Limit of a constant is a constant. Limit of a constant is a constant. So what I'm going to do is I'm going to rewrite this one. As you know, this whole thing is a 1 minus limit x goes to -1 of x is again -1. Be careful with your signs. This whole thing is 2. So this is -2. Limit x goes to -1 for x squared is nothing but -1 squared. And when I simplify this one, this is 1 minus 2, 1 minus 2 over 2, which is -1 over 2. Final answer. And let's go ahead and take a look. And that is what we have. Okay, step by step, always. Now let's take a look at the next one. What do we have here? So I have a limit. I have a function plus another function. What do? I distribute or I separate. This is limit x goes to 2, 5 times f of x plus limit. Again, do you have to do all of this? Nope. As long as you know what you're doing. So from my question, limit of g of x when x goes to 2 is 4. So this whole thing is 4. Now this is a constant. The constant comes out. So 5 limit x goes to 2 f of x. Bring down the plus sign. And I know that limit x goes to 2, the function f of x, the whole thing is -2. So this is 5 times -2 plus 4, which is -6. And you can see our answer matches. Now you can say, Miss, should I do all of that? Can I do everything right here? Of course you can. All right, let's go ahead and take a look at the next one. What are they asking me to do here? Here they're asking me to sketch the graph. When they ask me to sketch, I start with the first one so I can eliminate something that is not my graph. So let me go ahead and take f of 0 is 1. Look closely. F of 0 is undefined here. Oops. So this is not my function. Let me show you again why. Do you see this open circle? Open circle means it's not defined. So that's not what they said. They said f of 0 is 1. This is not my function value. This could be because as I can see, f of 0 is 1. Hey, wait a minute. Here I have an open circle again. So this is not my graph. Let's move on to the next one. Oh, this also could be because I do see the function value. So now I eliminated 2. Let's see what's happening. So when approaching from the negative side, the function goes to 3. When I approach from the positive side or the right hand side, the function goes to 1. So right hand side is 1, left hand side is 3. Let's see. Left hand is 1. So definitely not this one. My only option is this one. Let's see. When I'm approaching from the left hand side, the function value is 1, 2, 3. Yes. When approaching from the right hand side, the function value is 1. So this is my final graph. Again, how do I check? I start with the function value, which is 1, And when I'm approaching from the right hand side, I am approaching to 1. When I'm approaching from the left hand side, I'm approaching to 3. My function value is 3. Okay? Now let's go ahead and take a look at the next one. Oh, they're asking us to find the limit. You know, the trick here is you always have to factor this. So as soon as they give me something like this, I try to factor. Let's see, what are my factors of x squared minus 5x minus 24? They are x minus 8, x plus 3 over x minus 8. And I can see x minus 8 cancels. So my ultimate function is simply x plus 3. Now my life is so easy. Let's see. My option A is limit f of x when x goes to 8. So let's do it step by step here. Now I simplified that function to x plus 3 and limit x goes to 8. How do I do this? Again, this is a constant. So constant stays constant. Limit x approaches to 8, the function value or the value of the function when the limit approaches 8 is 8. And this whole thing is 11. There you go. Now I have 11. So just by factoring and canceling, you simplify your function. And if you look closely, I don't have to use all of this. I can only use my x plus 3. Now let's go ahead and do for the next one. Now I'm looking what happens when limit goes to 0 and when limit goes to x minus 3. So here I'm going to expand. What happens when limit goes to 0 for x plus 3? What happens when limit to negative 3 for the function value x plus 3? Again, limit of x when x goes to 0 is 0. Limit of a constant is constant. So this is 3. Limit of x when x goes to negative 3 is negative 3. Limit of a constant is a constant. So this is 0. Let's see. So when limit x goes to 0, the value is 3. Yes, that's what I have. Limit x goes to negative 3, the value is 0. That's what I have. But the key here is to factor it. Keep that in mind. Now let's go ahead and take a look at the next one. Again, you can use any methods of factoring. Here they're asking me to find when limit x goes to 3, x goes to 0, x goes to 1. So let's go ahead and I'm going to use this space to factor it. Factors of x squared plus x minus 12. I'm going to start with the simple one. Did you see that? This is going to be x plus 4 times x minus 3. Now factors of 2x squared minus 5x, of course you can use any factoring method. This is going to be 2x plus 1 times x minus 3. And now I see that x minus 3 cancel each other. What am I left with? 2x plus 1 over x plus 4. Now this is my function after simplifying. What am I doing? I'm trying to see what happens to the function when the limit goes to 3, limit goes to 0, and limit goes to 1. Let's go ahead and work it out here. So my function was f of x is equal to 2x plus, what did I say it was? 2x plus 1, yeah. 2x plus 1 over x plus 4. First is when limit x goes to, I forgot again, x goes to 3. The next one is when limit x goes to 0. And the next one is when limit x goes to, God, I keep forgetting, 1. Now you can go ahead and separate the limits for the top and the bottom and do it, but I'm just going to do it from right here. So this is limit of 2x plus 1 over x plus 4. Actually, I'm going to move this to this side and I'm going to simplify this one. So limit x goes to 3, 2x plus 1 over limit x approaches 3, x plus 4. Let's do this. Limit of a constant is a constant. Limit of a constant is a constant. So this is 1 and this is 4 plus and plus. Do you see that? Now, limit x approaches 3 for 2x is 2 times 3, which is 6. Limit x approaches 3 for x is 3. So now I have 7 over 7, which is 1. This one looks like a 7 actually. I'm sorry. Dun. Smaller eraser. Now let's do the same thing here. Limit x approaches 0. What's my function? 2x plus 1 over x plus 4. Now when you're doing it, you don't have to do it all the time. I can just, let me show you what I'm doing. So limit of a constant is a constant. Constant is a constant. Limit x approaches 0. X is 0. When limit x approaches 0, 2x is also 0. So here I can simply put 0 plus 1 over 0 plus 4, which is 1 over 4. Now let's look at the next one. Again, do you have to do the limits like we did before? You don't have to once you get the hang of it. So limit x approaches 1 for a constant is a constant. Limit x approaches 1 for a constant is a constant. So this is going to be plus 1 plus 4. Limit x approaches 1 for 2 of x is going to be 2 times 1. Limit x approaches 1 for x is 1. So this is 2 times 1 is 2. 2 plus 1 is 3. 1 plus 4 is 5. So this is limit 3 over 5. And this is the value 1 over 4. So when your limit approaches 1, your function value approaches 3 over 5. When x approaches 0, your function value approaches 1 over 4. So when x approaches 3, your function value approaches 1. Now let's check if we have the same answers. 1, 1 over 4, and 3 over 5. Again, if you're working out a problem and if you have a question, please make sure you take a screenshot and comment in the comment sections below. Good luck.